Okay, this is lecture number 8, a series of the lecture in digital image processing. Um, and today I would like to talk about the image geometry and continue in the translation, rotation, and so on, scaling, and so on. Lecture number 7 was about the arithmetic logic operation. And today is lecture number 8, is about geometry of the image. For instance, we have a coordinate where the image is x, y, z. Suppose for instance, this the first one is translation. Suppose that they take the translation coordinate to XYZ to a new location X0, Y0, Z0. And we have an object in, let's say here, we have an object like this. We want to translate it to a new position, or maybe scaling and maybe rotating. So I will talk about in detail later. For instance, the original image is for instance, the point is the point is here. Uh, let's see. I move here. This slide. Oh, right here. Move this slide. The original point x, y, z to new location x0, y0, z0. Then new coordinate will be x star, y star, and z star with this equation x plus x0, x previous coordinate y plus y0, and z plus y z0. This x0, y0, z0 is to displacement the new location. And new coordinate is x star, y star, z star. In order to make it in the matrix relation, we make we have 3 dimension here, but 3 dimension here, but we add a 1 here and make a matrix of 3 by 4. So when you perform this multiplication, matrix multiplication is 4 by 4 inside, so the result is 3 by 1. 3 by 1 x star y star z0 star, and exactly x plus y0, y plus y0, z plus z0 is the result of this matrix multiplication. But remember, the matrix is just adding 1 here, 1 here, 1 here, and 1 at the end of the input point x, y, z here. Then the matrix is 3 by 4. It is often useful to concentrate several input transformation and so on. With the remind, if you want to make it 4 by 4, then it's better to make it like this. This is maybe better to add 1 here, an extra 1 here, 1. So it is this was 3 by 4. Now it becomes 4 by 4. So the 1 by 1 equal 1 doesn't matter. So this is better to show like this with this in mind. So the use of the square matrix, you want to make a square matrix, simplify the notification representation process of coordinate considerably. So in this equation will be with this 2.53. And if you have an object with several points, then you can say that V star is equal A. A is this matrix, V. V is 4 by 4 matrix, V and V star. Maybe it is many, an object with many, many points. So let me continue from this. Maybe it's better. So with this, for instance, we have V is X, Y, Z one, and this is a translation. And for the new one is V star X star Y star Z star one, and the translation is this. And the translation or transformation, you can say translation is for translating one location from one location to another location. So this is the matrix, 4 by 4 matrix operation. Next one, let me bring it down here. Little down here. Next here. So this is here, and then the scaling. Scaling is like this, that we have a factor of x, s, x, x, y, s, z. Along the coordinate is x, y, z axis, and the transformation matrix become s, x, s, y, s, z one. This is a 4 by 4 matrix. Another one is rotation. Is rotating the object on here. So here is this one is translation. Let me, okay. So this is the translation, and then um, scaling. Scaling is just the, as I said before, here is just multiplying the S by the S matrix by X, Y, Z one. Rotation is also very important here. For instance, you want to rotate over X, Y, around of X or Y or Z axis. If you want to rotate the, let me go to this one is better maybe. If you want to rotate again, rotation, rotation. Okay. Scaling is here. First, scaling is x star is s x x, y star s y y, z star s s z z. This is scaling this cube, for instance, into the new one. So the new coordinate is x star y star z star, and the transfer origin point is unchanged. The original is unchanged here. So this 4 by 4 matrix multiplied by this 4 by 1 matrix, then the result is 4 by 1 as output. This is the scaling. For image geometry for rotation, an object about the, for instance, x-axis. in around the x-axis, you want to rotate this lamp from here counterclockwise here, counterclockwise. You want by theta, you want to come here. Then new coordinate become like this. X doesn't change, so 1, 0, 0, 0, and y is cosine theta x by theta x, not on 90 degree, any degree, theta x minus sine theta x and sine theta x, cosine theta x and z. This is for yz changes, but x doesn't change because x, we are rotating uh, the object about x-axis. In this case, the object is moved only y, z are changed, and while x is the same. The next one is the same. This is rotating the frame about x-axis. If you want to rotate the frame, it's different. For instance, you want to rotate the frame, but the objects remain the same. In this case, then it's kind of reverse. So it is minus sine theta here, but here minus sine theta is here. The cosine doesn't change as you compare here. So you are rotating the new coordinate is old coordinate is x, y, z, and new coordinate is x star, which is same as x, and y star, z star. This is in this case the object is not moved. The frame is rotated instead. This is another thing. It's kind of uh, inverse rotation or something like that. Later I will tell you. In the case of rotating over y-axis, again, y doesn't change, but x and y and z will change. In this case, the object is moved, only x and z are changed, and y still the same. Again, if you want to remain y-axis and rotate counterclockwise, I mean the frame, the X, Y, Z, around the Y-axis, you want to rotate the frame, and the new one is X star, Y star, Z star. Y star doesn't change, but it's the same as before here, but only sign become minus here. Here is minus, but here is minus is here. So it's kind of the inverse matrix. In this case, the object is not moved, the frame is rotated. This is also another case. Also for the z-axis, the same, z doesn't change around the z-axis, and xy will change. Xy are changed, and z is the same. If you want to rotate the frame, in this case, the object is not moved, the frame is rotated. And concatenation and inverse transformation is here. For instance, if you want to make translation, scaling, rotation, then you have to make this matrix one by one. So the order is important. First you translate, then scale, then rotate. And remember, the order of the multiplication of the matrix are important. You cannot change it. If change, then maybe the result is different. And the inverse is this, as I said, is this. Here is T inverse, the inverse of translation or inverse of the rotation. I can show here maybe for you on the book for the inverse. For instance, here, oh, sorry, I have to move around here. So, okay. Sorry. Uh, little complicated here. Okay. So I told you about the rotation and so on. Let's again, I check for you. What I did for you is here the translation and the problem is the okay, here rotation, scaling, rotation. I told for you, and this is around the z-axis here, and so on. Ah, this is even many transformation discussed above have the inverse matrix that perform opposite transformation and obtain the object. Obtained by inspection. For example, the inverse translation is T inverse is like this, or rotation inverse is like this. Let me continue. And so on. You can do inverse for many other ones. So here I think this will be finished this chapter. If I have more, let me see. No, it's okay. So once again, in this lecture, we just talked about the uh, three three translation, scaling, rotation. We have objects, so you want to translate or move it or scale it like this or rotate it like this. And for one point or many points in one object. The translation is this. You want to make a 4 by 4 matrix, so you add a 1 here. And then this I will explain detail later. Or you want to displace the object is like this. This is the figure for this. But here you are transforming the translation of frames. So you are changing the origin from 0, 0, 0 to x0, y0, z0. This is this one. It's like inverse transformation. And the scale is this, as I told you before, and the rotation around the x-axis, y-axis, and frame rotation, and y-axis, and frame rotation again, and z-axis rotation, and frame rotation around the z and z axis, and concatenation and inverse transformation will perform with this uh, multiplication of the matrix in the order. Remember, it should be in the order, and the inverse transformation is like this, as we said here. I think this part, lecture 8, will be finished very soon, in maybe 20 minutes, and lecture number 8 will be finished here later. I would like to talk about more serious like perspective transformation, which is very important, and also object, I mean, I mean perspective transformation, and also with two camera you can measure the distance for robotics, and measuring the distance by two camera as as human being, I mean, does the same with two eyes, can recognize the I mean, the distance of the object ahead. So with wide camera, you cannot do this unless otherwise you have the speed of the vehicle. And this is good for robotics. And this is the next lecture, but not now. And here I finished. And thank you for listening. Here I stop. Thank you.